let me fly through these problems as quickly as I can here. Okay, so the first one, given some stuff here, find the number of terms in the arithmetic series. So, boom, that tells you which formula to use. The arithmetic series formula says S sub n equals n over 2, a1 plus an. What was the goal? Find the number of terms. So, that's the goal, to find the value of n. What are we given? We're given a1, the first term, that goes here. We're given a sub n, the last term that goes there. They even tell you the series 705 goes here. So drag and drop these numbers into the formula. So we have 705 equals n over 2, because I do not know what n is, parentheses. I know what a1 is, it's given, plus I know what an is, that's there. If you want, I saw people getting rid of this 2, like right away. So you can multiply both sides by 2, that's fine. Bye-bye, bye-bye. That'll be 1410 equals n times, we can multitask this evening, Casio. 2 plus 137 over 2, hit enter, 141 over 2, boom, 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 boom. Now, the goal is to get n alone, so I'll multiply by the reciprocal, which is 2 over 141. 2 over 141. Bye-bye, bye-bye. Go Casio here. It'll tell you that 20 is n, so n is 20. What was the goal? To find the number of terms. The goal was to find n. We have. We can move on to the next problem. All right. Evaluate the IGS, the infinite geometric series. The infinite geometric series looks like this. Remember that? However, you only have permission to use this formula if this is true. So we have to find r. R equals, well, it's any term divided by the term before. So go 6 over 35 divided by 3 over 7. Let's see what that is. Casio. So we have 6/35, and we're going to divide that by 3/7. Hit enter. R is 2/5. See that right there? 2/5. So R is 2/5. And the absolute value of 2/5 is 2/5, which is safely less than 1. So do we have permission to use this formula? You betcha. This is your first term, and this was R. So drag and drop them here. So A1 is given 3 over 7 over 1 minus, and then R was 2/5. So see what we got. So we have 3 over 7 over 1 minus 2/5. Hit enter. That says 5/7. So your infinite geometric series would be 5 over 7. Okay. All right. Evaluate this one here. So this is a series. That's what that symbol means. But what kind of series is this? Is this arithmetic or is this geometric? If the directions tell you, great. If not, you have to decide for yourself. To make that decision, look at this beast here. Look at this monster. Does this look like arithmetic or does this look like geometric? This looks like a geometric sequence. So this is going to be a geometric series. The formula for which says this. Remember this one? Okay. It's a geometric series. You need 3 things. You need to tell it what n is. You need to tell it what r is. And what a1 is. So r, your common ratio, is the stuff that is being powered. 5/3. Okay, that's 5/3. N is the number of numbers being added. For that, you go top minus bottom plus 1. So top minus bottom plus 1 equals 4. That's how many numbers are being added all together. 4 of them. A1 is the first term, which is discovered by looking at the index. The index begins at 2, so plug in 2 for k there. So it'll be 4 times 5/3 to the power of 2 minus 1, right? 2 goes in for k here, it's this. The calculator would say 20 over 3. So 20/3 is playing the role of the first term. Notice I don't have to plug this into here because this formula doesn't care about the last term. It cares about the first term, which is found by looking at the index. It wants to know r, which is this, and it wants to know n, which is top minus bottom plus 1. So now take these values and drag and drop them into here. So a1 is 20/3. 1 minus r is 5/3 to the power of n, which was 4, close that door, over 1 minus 5/3. And we now type this in and we hope for the best. 20/3 times 1 minus parentheses of 5/3, close that to the power of 4, close that door, all over 1 minus 5/3. We hit enter, and what do we have? We have 5440 over 81. 5440 over 81. Looks good. Let's keep going, okay? A couple more. Fill in the blanks geometrically. Geometric. So geometric is when you go from here to here by multiplication. So if that's 5, this could be called 5 times r. And this could be called 5 times r, otherwise known as 5r squared. And this could be called 5 times r cubed. And these are set equal to each other. So 5r cubed equals 16.875. Let's divide by 5. Okay, so 16.875 divided by 5, 27/8. So I have r cubed equals 27 over 8. If I take the cubic root of both sides, the calculator is going to tell me that r is 3 over 2. So now take 3 over 2 and plug it in there and there. If you plug it in here, it'll tell you that this is 15 over 2 and that this one is 45 over 4. The goal is to fill in the blanks. We have, these are the 2 blanks, okay? Right there, these are the 2 blanks. All right, last one. What we got? Find the 50th term given this sequence. Is this arithmetic or geometric? Well, this is arithmetic because they're subtracting 3 every time, right? So this has a common difference. And the common difference would be 2 minus the piece before. That's -3. And all of these are separated by -3. So that's how I know that this is arithmetic, right? Because you're subtracting 3. In your arithmetic sequence, your explicit rule, as they sometimes call it, looks like this. an equals a1 plus n minus 1 times d. Get into the habit of putting parentheses around this. We know what a1 is. So here is my rule activated, so to speak. Right? I filled in a1 and I filled in the common difference. Now I can use the rule to find the value of anyone. I want to find the 50th term to finish this off. So plug in 50 here and here. So the 50th term would be 5 plus 50 minus 1 times -3. And we got 5 plus 50 minus 1 times parentheses, -3. We got -142. That's the 50th term. We're done. We move on.